So, you guys came to hear about some comm stuff. And there's a lot of things we could talk about. I have a little bit of a story I want to tell you because in playing with a lot of things recently, it's been a really weird couple of years for me. I'm classically associated with comm, but I haven't done that much pure comm work in the last 2 years. I spent a lot of time working on SOAP. I spent a lot of time in the JVM, the Java Virtual Machine. Spent a lot of time with the Microsoft Java Virtual Machine, which is a pretty interesting piece of software, and a few other things which are, immaterial to this part of the talk. I've kind of like reinvented my understanding of comm. And it's about something different than I used to think it was about. And so I'm going to tell you what I think it's about. And hopefully that'll help you guys use the technology more effectively. So I want to go through that for sure. But there might be some other things you guys want to hear about. And since we're kind of loose, it's kind of towards the end. I don't need to take an hour and 15 minutes to spew about what I want to talk about. So that'd be kind of fun to just have you guys drive the talk. I mean, so much of these talks are some Microsoft marketing guy gets up and tells you how Windows DNA and XML are going to, e-commerce enable your B2B porthole, right? And, I think that maybe you've had enough of those talks. I could be wrong. I can certainly give one. I've given one of those in my life, and it was amazingly fun. We'll never do it again, but so why don't we just... Oh, okay. Boy, I thought I actually did something worthy of your praise. Oh, okay. Great, fine. Fine. You guys do what you want. So, I know what I need to tell you, but I know that I can squeeze in a few other things. So why don't you guys yell out an issue or two you would like me to address during this talk? Attributes, thank you. Anything else? Performance. Okay. What else? Which points? Connection points. What else? I just realized what the problem is. You know his real name is Francis Joel Klein, right? So it's like F. Lee Bailey, F. Joel Klein, right? It's totally, you're not getting the joke. Oh, well. God. So anyway, oh, by the way, I don't work at Microsoft, so. That's good enough. I think that covers it. Well, guess what? You'd have to beat me not to talk about that. You'd have to beat me not to talk about that. These two will come up. This will definitely come up. Reliability, sorry. If we have time, there's really not much to say with respect to comm. Comm doesn't really have much to do one way or another with reliability. Comm is an RPC technology in terms of what you're probably thinking about, and it's not a reliable RPC mechanism. If you want reliable RPC, you want to use MSMQ, right? And build stuff using MSMQ, which gives you reliability. Connection points, sure, they still suck. Okay. So good. All right. So that basically what you're saying is you want to hear the talk I was going to give anyway. Great. I love that. I love when that happens. But see, now you feel like you're empowered and you have contributed to the table of contents of the event that you're about to take part in. All right. Cool. Okay. Well, everything you need to know about COM Plus can be discovered in a tool you already own. And that tool is Visual C++. Even if you're a Visual Basic programmer. By the way, how many people in the room are VB programmers? Be proud. How many of you work in C++? Oh, what happened? I thought natural selection had taken its course with you people. How did they let you out? Aren't you supposed to still be back writing code? The VB programmers get like 7 months a year off or something, right? They're so damn productive. Yeah, those damn VB programmers going home early all the time, spending time with their wives and your wife. Okay. Damn that tool. Damn that tool. Okay, so COM, in and of itself, right, just straight COM, Brock-Schmidtian era COM, right? All of you remember Craig Brock-Schmidt, right? He wrote the Old Testament of COM. It's called Inside Olay. And what COM did was it said load library is an interesting thing, right? How does load library work? Load library takes the name of a file, takes a very physical, low-level, grungy detail, which is what file contains the code, and brings it into memory so you can use it. And then we resolve entry points by calling getProcAddress. That's how pre-COM worked with DLLs. Load library, getProcAddress was the way we did everything. And the problem was it was very type ignorant. Right? If we changed the semantics or syntax of any of the data types we were using across the DLL boundary, we weren't getting any help and love from the system. Right? We weren't getting any support for doing type-aware component software. Right? A straight DLL that you load via load library getProcAddress is an untyped DLL. Right? And you're kind of manually constructing the type system on top of it. Well, what COM did was it said, we're going to introduce type into the loader. And when we load code, we're not going to load code based on file names. Rather, we're going to raise the level of abstraction 1 degree. And we're going to load code based on concrete type name, which is a class name. So in Visual Basic, you say set foo equals new foo. And foo is the name of some chunk of code out on your machine or somebody else's machine. And based on the type of code you wanted to load, we figure out where it is, what machine it should be on, and we bring it to life, and you're just a happy camper. Right? And that's the way COM works. The way we resolve entry points is we never do getProcAddress. Rather, the last 4 functions that you ever export from a DLL have been defined. What are they? DLL getClassObject, DLL canUnloadNow, DLL registerServer, and DLL unregisterServer. In the world of COM, all components export those 4 entry points and no other entry points. And only one of them is actually even interesting, and that's DLL getClassObject. That is the orifice through which COM reaches into your DLL, finds the particular piece of that DLL that we need, and brings back a reference to it. And that's your class factory. Okay? And DLL getClassObject is really the only function that's interesting. And it is from that plus query interface, and IUnknown, that we resolve all the entry points. Right? If you do a dump bin / exports on a COM DLL, it's very boring. Right? If you do a depends on a COM DLL, the exports that it spits out are pretty uninteresting. Right? Rather, we add type-aware metadata so that we can do a dump bin / exports in a meaningful way. And what is that metadata? It's a type library. A type library gets added to your component DLL so that instead of doing dump bin / exports, we do OlayView. And OlayView figures out not just the 4 functions that you export, it figures out what pieces of named code you've got and what interfaces they support, and what common interfaces they share with other DLLs. Right? Given 2 straight DLLs, pre-COM era DLLs, if they exported the same function, Bob, how would I know that it was the same Bob? How would I know that if I called Bob on the first DLL, I would get roughly the same behavior as calling Bob on the second DLL? I mean, Bob, that's a pretty vague string, right? That, it doesn't say a lot. Whereas with COM, if we have an interface called iBob, it's strongly named with a UUID. And those things never collide. And I can tell that if you support something that says iBob with a given UUID, and this guy supports it with the same UUID, that's a strong name. They are identical. I can expect the same semantics from both DLLs, which tells me they're plug compatible. That I could drop this one and put that one in and it would probably work, maybe, right? I have a much better clue than I would without it, right? And of course, this stuff is always hard, right? COM just makes the able more able. It doesn't, give you magic and solve all your problems. But it gives us a framework for at least reasoning about what a component is and how we can talk to it. So it's just, it's a set of ideas that you can use or not use at your will. All right. Well, that's COM. And so really the idea behind COM was that we introduced type into the loader. Okay? Now, Let's go back to Visual C++. I'm going to make a new project. Everything you need to know is in this dialog. Redist, TechEd. Okay. In fact, there are really only two options we care about. The two that I am showing you right here. Win32 application and Win32 console application. All right? Understanding the difference between these two is the key to understanding how we get from COM to COM+. Okay? If you can understand the difference between these two, and I will try my best to explain it to you, then you know COM+. We can just call it a day early if you want. Okay? If I am struck dead by, the Justice Department hit squad, during this talk, as long as I get through this part of it, we're totally cool. All right? Okay. So let's start by selecting Win32 console application. Now, I will call this ConApp. Yes. Those of you who have read the great book, The C Programming Language by Brian Kernighan and Dennis Ritchie, probably recognize this dialog box. It's the first screenshot from chapter 1, which is where we write hello world. And I will indeed write hello world for you with one finger. Watch. And while this thing builds, let's go take a look at the code. And just like in K&R, there's our function main, returns int, takes int and a char star, and calls printf, and then returns 0. And of course, just like all good programs, it includes standard AFX.h. All right? Make sense? Now, let's run that wizard again. This time we're going to pick Win32 non-console application, and I'll call this one WinApp. Hey, did anybody win the car? Is that person in this room? I'll go double or nothing with you if you want. Wouldn't that be fun, to have won a car and then lost that same car at TechEd? Wouldn't that be cool? Just think of the stories you would have to tell. I asked Don Bach, I thought I knew the GUID for Excel, but Don Bach said it wasn't, and I lost the car. Oh, man. I'm going to select the same option this time, a typical Win32 application. Hello. Hold on. Wow. Never had that happen. Win32 application, WinApp. WinApp that works. Great. All right, so let me build this thing, and while it builds, let's take a look. We have just written the same program, by the way. In both cases, we have written a program that displays the string hello world to the user. If our manager had come to us and said, please, Don, write a program that displays hello world to the user, we could submit either of these programs and feel good that we have done a good job that day. Of course, it only took us 30 seconds, so we might feel a little guilty, but hey, that's okay. It'd be nice to feel like a VB programmer once in a while. I mean that in the nicest way. So as you can see, the exact same program was generated this time. The white space handling is a little bit different, which is why it looks a little bit different in this editor. I think they changed the tab stops or something. But it's the same program, right? Let's run this program. So there it is, hello world, right there in the middle of the screen. You've seen it. There, are you happy? Great. Now, the interesting thing to do is to run the other program. Switch back to the other program. Of course, the MRU list got tanked when MSDev visited another universe. There we go. So let's go run this program. Redist/TechEd. So that thing is in the ConApp directory under debug, and there it is right there. Now, Look at that program. What's it going to do? It's going to display the string, hello world. Agreed? Watch. There. Do it again. Don't look at me. Don't look at me. Look at the screen. Don't look at me. Look at the screen. Look at the screen. Don't look at me. Look at the screen. There. See? You didn't look. Come on. Look. There. I think with this strobing effect, you can see that there is a hello world up there. At least I can see on my screen. There you go. Who said process creation wasn't cheap on Windows, right? There you go. All right. So I made my point. It worked, right? Now, first off, where the hell did that window come from? I did not call create window anywhere in my program. Where did that window come from? Well, it's a console window, which is a special kind of window under NT. I don't know if they have them under Windows 9X or not. But under Windows NT, a console is a special kind of window with its own API for managing it. And the function that was used to create that thing was called alloc console. Alloc console is a Win32 API which creates one of those black windows, hooks up the 3 standard handles for input, output, and error to the well-known place in your process, and lets you do I/O against them. Okay? And that's how printf works. So here's the question. Who called alloc console? Let me bring up a shell. So let me cd to conapp. Actually, I'll just stay up here. Let me do a dump bin /imports. This is going to tell me all of the symbols that I am dynamically linked against. So it tells me all the API calls I make. Right, so if you ever want to walk up to a DLL and say, what do you use? This is a good way to do it. So I'll do a dump bin /imports on conapp /debug /conapp.exe, which is our binary. And there's the list of APIs that I call. Okay? Now, of course, that's a really long list. What I need to do is grep for the word console, and we'll see all of the console APIs that we're making, all the calls to APIs that we're making. So there it goes. Set console control handler. Who called that, by the way? The C runtime. The C runtime called set console control handler so that when I hit Control C, it terminates the process. Because I didn't know if you knew this. That's not the default behavior. Evidence would be Microsoft Word. You know, if Microsoft Word, terminated when you hit Control C, then you would never want to copy text, would you? It would be a bad idea, right? So obviously, they hook it up after the fact so that when you hit Control C, you can terminate the process from the outside. But they don't call alloc console. So I didn't call it explicitly. It wasn't called by the C runtime. Who called it? The loader. That's right. The loader. The loader called it. The loader is who? In this scenario, what API represents the loader in this overall picture? Create process. Right? There are 2 APIs to the loader in Win32. Create process and load library. Those are the 2 ways you get code loaded in the core APIs. Right? One of them says load it into my address space, that's load library. The other says make a new address space, load it in there, and start executing. In fact, in both cases, we start executing right after the load. Right? That's what DLL main is all about. So the loader is the one who called alloc console, not us. And here's an interesting question. How did it know? If I launch my Windows app, will it create a console for the Windows app? No, it doesn't. Right? When you double-click, Word or something, you don't see that flash of black for a moment. Right? It doesn't stick around. So given that, how does the loader know? Does it grep through our source code, or our binary code, looking for opcodes that call out to printf? And it knows, oh, the printf guys need it. No, it doesn't. Instead, it uses an attribute. And let me do a dump bin /headers. And this time, I'm going to grep for the string subsystem. And notice that, let me scroll that up so you can all see it. Notice that the subsystem version is 4.0. Who cares? That's not interesting. But the subsystem number is 3. And dump bin will tell us what 3 means, which is Windows Console User Interface, or CUI. So we've built a CUI app, right? You're a CUI programmer. There are CUI frameworks out there. I can feel a new industry being born right here. Now, let's do a dump bin on the Windows app. Pardon me? Oh, WinApp, that works. Thank you. It's so useful having hundreds of people watching you while you type. You know that extreme programming stuff where you have 2 guys at the same keyboard? They got nothing on this. This is really extreme programming. If you really want to make sure you write good code, you need 400 or 500 people in the room and a projector. And I guarantee there will be no bugs. There you go. Notice that this time, the subsystem number is not 3 like it was before, but rather it is 2. So, what has happened is when we wrote the code that called printf, we threw a linker switch, which is how that thing gets set. We threw a linker switch that told the loader what our expectations of the world were. That is, we expected to have a console, or we expected not to have a console. And the loader called alloc console when it needed to for the console app, and it doesn't call it for the Windows app. Right? What happens if the Windows app calls printf? This is one of the great, deep philosophical questions of computer science. If a Windows app calls printf, will anyone see it? And what's the answer? No. It goes to dev null, right? If you're a Windows app, those 3 standard handles are piped to null. They go nowhere. They go to a bit bucket. But if you're a console app, they go to a real console. Okay? Make sense? So, the Windows app doesn't have it. The console app does. We're basically describing the intentions and expectations of the code. And the loader is now becoming aware of those expectations. Now, here's another interesting question, which I think is really important for this particular talk, which is, what happens when I run the console app from here? Is it going to flash up a new black thing? No. See? Rather, the loader is a really smart piece of code. The loader goes through the following algorithm, and we're going to go over this 18 times. The loader looks at the requirements of the target code that we're about to load, compares those requirements to the environment we are currently running in, which is our process, and tries to propagate the properties of the parent to the child. So we try to take the console from the parent and give it to the child so he can do I/O against it too, right? And in this case, we had a console in cmd.exe, which is the shell, and we just propagate that down to the child process. And that's the way it works. But in the Windows Explorer, when I launched it, the Windows Explorer is itself a Windows app that does not have console handles. So the requirements of the target code were, I need a console. The place where we were loading from did not have a console, so the system, the loader, created the console so the code could execute correctly. Got it? That is the model of COM+. Great. Give it up. Yes, there you go. All right, fine. So, COM+ takes the typed loader that we know from co-create instance and adds extensibility points to it so that we can achieve what we just saw with that console app. Right? We have the ability in COM+ to annotate our COM classes, which are the units of code, with attributes that describe our requirements and expectations. And it is the job of the loader to look at those attributes and ensure that our code gets what it needs. And if it can't get what it needs, it fails the co-create instance call. Tries every way it can, but once in a while it has to fail. And that's good. All right, cool. The best way to think of COM+ attributes is to think of these things called mix-ins. And mix-ins was a programming style, I think Common Lisp Object System, CLOS, was the first place where it became popular. It was big in the 80s, right, early 80s. And the idea behind mixins was we had all of these base classes that we could just bring in through multiple inheritance, and they would just magically annotate and enhance the type that we were programming with. So the best example I can think of that you might be familiar with, because nobody does class, would be the impl classes in ATL. Right? If you've ever used the ATL impl classes, that's a very mix-in style of development. You're mixing in an implementation of this and of that and of the other thing. Right? And that's what attributes are like. Attributes indicate the requirements of a COM class. They can indicate which extended services you want. There's a built-in set of services today, and that list of services is only growing. Attributes are examined at instantiation time when we load. And what happens is the loader actually augments your object with additional goo based on what your attributes are. This is probably the most important slide in this talk. What it does is it shows you two styles of design, two styles of implementation. Right? The top one is classic OO stuff, where we have a bunch of mix-in base classes that bring in functionality into our class. So notice that my class extends transactional object, synchronized object, and poolable object. And I'll assume that those are actually implementation classes that have real method implementation code and add methods, do all that stuff. And then also notice that we implement a signaling interface, java.lang.serializable, which is another way to indicate that we support or it requires some service. Right? So those are two styles of doing the same thing. Well, that's, straight, OO language stuff. The bottom is attributes. Right? The bottom says those mix-ins, it's not like what I want is to be able to say I've got a pointer of type transactional object. Right? The idea behind mix-ins is we're not looking for polymorphism like we are with interfaces. We're not looking for, I want to support this interface so you can hold that kind of reference. That's not what mix-ins are about. They're about, give me some chunk of code to make my object better. Right? And that's what attributes are about. Attributes are about making your object better by having these extra types that get associated with you. So the bottom example just shows what a mythical COM+ language would look like when we have attributes integrated into it. And obviously, future versions of Visual Studio will have attributes built into them. Right? And until that happens, I'm hand waving. There, that's what it looks like. So, where are the attributes stored? Well, the loader is the guy who has to look at them. And in an ideal world, we'd put them in the DLL. In an ideal world, we would store the attributes inside the DLL, either in the type library or in some other file. And the loader would just look there. But you know what? We have a problem. It's called Visual Basic. Visual Basic is this big tool that a few people, use. I'm sure you're aware of that. And Visual Basic only ships once every 4 years or something like that. They do it on every other election year or something, right? So they do it in the 2s and 6 years. And the idea is Visual Basic is not extensible, so there's no way to get VB to emit anything other than what the VB team wants to emit. And the VB team is very busy, building web classes and all these flashy features for trade shows. And they didn't want to, they couldn't be bothered to support attributes in VB6. So the COM+ team and the MTS team were forced to come up with their own offline version of a catalog for these attributes. So there's this thing called the catalog manager. It exists in both MTS and in COM+. And it basically allows us to add attributes to COM classes. And the catalog manager keeps HKey class's root/class ID in sync with the attribute store. And the idea is we walk up to the catalog manager, say, here's my DLL, do stuff with it, and voila, it happens. Let me go ahead and do this for you really quickly, although I'm sure many of you have already done this. Let me test fate and run another app wizard. Let's call this, what's in the news? Let's implement Joel Klein in COM. I may be misspelling his name, but I don't know if that's the case. So here we go. And let's see, we have to have some operations we would like to perform on Joel Klein. Oops, I forgot something. Insert ATL object. There we go. All right, so here we go. Set an operation. What could we ask Joel Klein to do? How about have mercy? Okay. Another one would be, I don't know, what else could we ask him to do? Resign might be a useful thing. Or how about this? Become counsel at Microsoft. That would solve the problem. You know, think about it. If we could hire Joel Klein, I don't work at Microsoft, but if Microsoft could hire Joel Klein for maybe $500,000 a year, wouldn't it be great? It would just solve all these problems. And if they could just hire Scott McNeely for a few million, it would be great. They have the money, they could do it. That shows you they're not unfairly using their stranglehold power. Okay. So we have a couple of methods. Let's put something dopey in one of these things so we can see it work. And what do we want to do? Well, this is a trade show demo, so it wouldn't be a trade show demo without message box. Okay, I was wrong. What was I thinking? I'm sorry. Sure, I wasn't here. I'm sure glad I wasn't here for the speaker briefing where they told you don't talk about the Justice Department thing. Okay, let me build the component. And what's happening now is a piece of code has been built. And that piece of code has no attributes. That is, when you take a DLL and build it, and just do a reg server 32, which is what all the modern tools do, the component has no attributes. That is, you have not told the loader about any special needs you may have. And what that means is you have no control over what happens to you. Let me give you a great example. Will this object have a transaction when it runs? Don't know. It didn't say one way or another, so the answer is it depends on who creates it. Sometimes he'll have a transaction, sometimes he won't. Will he have synchronized access? Don't know, depends who creates it. Right? We've made no statement about our expectations through attributes, so we get what we're given. And we have no influence over what the properties are of our runtime environment. To have that control, we need to be an attributed class, or what we call a configured component. And let me make a configured component for you really quickly. Let me bring up Let me bring up a tool to stall you while I bring up the right tool. We'll bring up the Component Services Explorer, which is the user interface to the catalog manager. And what I'll do is walk up to him and say Component Services, Computers, My Computer, Com plus Applications. I'll make a new application. We'll call this one FApp. And away we go. So go to Components. And now let me show you the VC6 integration. The Com plus integration. They worked, they had like 3 engineers, 4 testers, 5 PMs building this integration layer. Let me show it to you. They didn't have enough PMs, right? So that's what's taking me so long. There we go. And so what happened was, in dragging the DLL into Com plus Explorer, we told Com plus Explorer to make a call against the catalog manager saying, I got this DLL. The admin or user or developer or whoever wants this to be an attributed component. Please go off and add a default set of attribute values to this class. And in fact, do it for every class inside the DLL. So it actually reads your type library, calls your DLL register server to figure out what you do, and then adds a set of default entries for each class in the DLL. Great. And we call that thing a configured component. Cool. Configured components are arranged into these things called applications. Applications are a unit of deployment. So we have the ability in Com plus to walk up to the catalog manager, like this, and say, OK, I've set all my attributes. I've got all my component DLLs, all my type libraries, all my proxy stub DLLs, all the stuff it takes, COM-wise, to make this work. Now what I want to do is get it ready for deployment. So I can right-click on this thing and say export and save it to temp/fapp.msi. And what it's going to do is read all the catalog attributes, read all of the DLL file names, and serialize them all into an MSI file. So now what I can do is delete this thing. I don't even need it anymore. It's gone. If I were to call co-create instance now, I get regdb enter class not registered, which is the H result you all know and love, right? But what I can do is redeploy in my own app, or in my own machine, rather. So to do that, I simply go to temp, and there's my fapp.msi file. The easiest way to do it is just to double-click it. And I can also put it into ADS and just push it out to all my servers, right? But I got a laptop with no network connection, so that's a hand wave, right? And if we look back now, we'll see that fapp came back, and if we drill into it, there's Joel Klein. And the DLLs actually, all the DLLs that are needed are embedded into the MSI file, so I can just ship that out, you know, pretty easy deployment story. And in fact, I can push them out either via ADS or using the catalog manager, because I can actually remotely configure machines. Because the catalog manager itself is a COM component that speaks DCOM. All right. So that's what applications are for. For what it's worth, applications don't have to map to the same DLLs. That is, I can have multiple DLLs contributing to a single application, and a single DLL can be split into multiple applications. All right. Now, attributes influence object activation and method execution. So the attributes of my class control what happens at runtime. They influence the semantics of my code, and it's really mythology to think that, you know, JRandom MCSE, the guy who just got done putting on the RJ45 connector, is going to be able to walk up to COM+ Explorer and do anything useful. Because those attributes are incestuously linked with the code that you write. This is just another design style. And so when I make changes to attributes, I have to be the guy who wrote the code more often than not, because the code goes hand in hand with the attributes. Let me give you an example. There's an attribute. In fact, hold on. I need to delete this because I need to rebuild the DLL, because I'm going to make a change to it. There we go. Cool. So what I'm going to do is set an attribute on the component that says, I would like to have an initialization string which is not compiled into my code, but rather could be set by an admin. Right? So I might have a setup program. I might document how to do this, what have you. And I'd like to be able to allow the administrator or someone at deployment time to change configuration data that's specific to me. The set of attributes is fixed, but this is the one attribute which is a backdoor into your application. And you can put anything you want in here. It's just text, right? And because this is TechEd 2000, what would we put in here? XML, of course, because it's not really Windows DNA without that XML magic. So there. Are you happy now? Okay, so I've got some XML in my initialization string. And now what I'd like to do is bring up America's favorite development tool, Visual Basic, and program against that component. So you'll notice that my VB sessions are always a little bit skewed, since I have the debug window open all the time. So let me do a set foo equals create object Joel Klein dot Klein. It tried to instantiate my code, but what happened was we got back an error. Co-create instance failed. And it says, class does not support automation. That's a VB problem. Or does not support the expected interface. Well, what happened was the attribute that we set works hand in hand with an interface that my object must implement. And if I do not, she blow up, like you just saw. What I need to do is go back to my C++ code and find the header file and bring in COM services and add support for the interface that was just looked for and I didn't support, which is called object construct. Okay? An iObject construct is an interface that goes along with that attribute and only that attribute. And of course, if I don't put it down here, it doesn't really matter, does it? So there we go. I have iObject construct. And now what I'm going to do is I have to implement the one method that is on that interface, which is called construct. And it takes an iDispatch pointer. And in that thing, what I'm going to do is declare a pointer to an hold on, make that bigger, an iObject construct string, ctor, hresult, hr equals pdisp, arrow query interface, ctor, ccom beaster, beaster, hr equals ctor, arrow construct, beaster, and then of course cool, there we go. And of course we'll return SOK because we want to work. All right, cool. I love message box. I've been thinking about calling, my wife's pregnant. We're having a new son. I was thinking I could call him message. The applause was because it did not compile. Is that what you guys do? Is that what it takes to win your love? Construct, oh, I'm sorry, I implement construct. I call get construct string. This isn't the Jerry Springer show. You don't have to clap with everything you agree with, right? Talk to the hand. Okay, it didn't link because my application is running. Let me rebuild. Okay, cool, it's built. I have the construction string attribute, and now when I instantiate from Visual Basic, there you go. There's my XML displayed in the default XML viewer on the platform. Okay, so does it make sense? So please note, the important observation is we set an attribute and it influenced the way we wrote the code. And if we didn't write the code correctly with the attribute, then she blow up. Right? So these are really just two parts of your implementation. All right, cool. Moving right along. So that was the attribute that I just set. It said my object had to implement that interface, and I would be passed an object that implemented that interface from which I would select the string out. You might be asking yourself, Don, why doesn't construct just take a beaster and get it over with? The reason why is we have a rich history of complexity in COM, and it's now's not the time to turn back. We've made a commitment, a long-term investment in complexity, and we're going to stay the course. Here's the inventory of attributes. I'm sure many of you have seen many of these. This is not so much about the particular attributes, but more about how the internal plumbing and what the programming model really means. So this is here for your reference. Great. One of the things we can use attributes for is process management. We can use it to indicate which process we want things to run in. And what happens is, if I configure my application to be what's called a server application, then all instances of the classes in that application will run in a distinguished surrogate process that is managed by the system. If I mark it to be a library app, then it runs in the process of the guy who calls co-create-instance. Remember, this is consulted at load time. So when you call co-create-instance, we figure out what application you're in. And if it's a server app, we see, is there a surrogate already running for that app? If there is, we put you in there. If there isn't, we start one and put you in there. Right? And that's the way process management works in COM. We're already marked as a server application, so if we look under COM+ applications, we'll see that the F app is already running, and it's running with process ID 3208. If I look under Task Manager, there will be a DLL host with the process ID of 3208. And I can actually, it's a managed quote-unquote process, which means I can walk up to it and tell it to do things. For example, I can have it do an orderly shutdown by doing a shutdown command, kind of like an NT service. Right? It's very similar to the NT-service architecture. So I've just told it to do an orderly shutdown, and what it does is it sends a well-known signal to all of its threads and waits. And if after 20 seconds, all of the threads have not done the right thing, we then start shooting them in the head with a terminate thread. So we try to do an orderly shutdown, but even when we can't, we go ahead and do a hard terminate. And of course, I can also tell the process to preload by doing a start. And there we go. Cool. Straightforward. Get rid of here. Okay, so there's a picture, right? We have some classes shown on the left. They're mapped to 3 different applications, A, B, and C. And if we look at the bottom, the table of applications, A and B are server apps, and C is a library app. So notice that the things that are in C, which is the class W, there are W's in all of the processes. Right, y'all see that? There's a W everywhere. Why? Because it's a library app. It says, I don't care what process you load me in. But the Y's are all together in the same process because they're configured inside of a server app. And the X's and Z's are all together because they're also in server apps. And in fact, the X's and Z's are together because they're in the same server app. See how that works? So that's how we control which process the code loads in. Why would we want to do that? Why don't we just have them all run in one big process? There's a whole bunch of reasons. One reason is, what happens when one of them tanks? Let's say junior engineer Jimmy, not you, of course, wrote some code and dereferences a null pointer just to see what would happen. Right? What happens when we call the method that does that? It tanks the process. So if we all ran in the same process, then it would tank all of the applications running on that server box. But by isolating them into distinct operating system processes, they only tank the classes that are running in that process, not in any of the others. Right? So it's a unit of fault isolation. It also impacts the way pooling works, pooling of various resources, both threads and database connections. And there's an impact in both directions, right? If we had everybody in the same process, then the pooling would be less efficient than if we partitioned the classes based on database usage, so that we had one connection pool for the database connections to that database and a different one for the connections over to here. Because the way the connection pooler works is very general purpose. So it's the same reason you might write a custom operator new in C++. You can do a better job of sub-allocation when they're all of the same type. Right? Again, process management is one way to accomplish that. So, deep cleansing breath, inhale. Deep cleansing breath, exhale. Remember, the attribute is like a mix-in. And mix-ins have the capability of doing several things. They can require you to implement some functionality. Have we seen that? Yep, that's what the constructor attribute did. It made us go off and write it. It's just as if it was a base class with a pure virtual function or an abstract method. Right? If we don't implement it, she no work. Right? Another thing an attribute can do is add methods to your object. Another thing an attribute can do is add data members to your object. Now here's the problem. Your object is pre-compiled using VC or VB. There's no way we can reach in there and actually recompile you, because we don't have that much information about what you look like. So we need something else, and that something else is context. And context is the linchpin of Com+. It is the one thing that is guaranteed to last from here till the end of time, because it's such a general purpose concept that it's amenable to so many different problem domains. And the idea is Com+ puts every object in a context. And the context surrounds your object. And what happens is every thread stores up in TLS. This is the international symbol for TLS, by the way. Would you do it with me, please? Make me feel better? More of you, more of you, more of you. Talk cannot go on until I get at least 50% coverage. Come on, come on. There you go. Yes. The current thread looks up in TLS, and you can stop doing it, sir. Every thread has a pointer in TLS that points to the context that we are currently in. And as you call from object to object to object, the system adjusts that pointer to point to the context of the object that we're invoking on. So what happens is, inside of our object methods, we can just reach out and touch the context by looking up in the TLS slot and grabbing that pointer. And we know it'll always be the right one for our object, because the system makes sure that as we jump from context to context, that the pointer flips. So here's what it looks like. There's a context, which is a real live thing that implements real live COM interface pointers. And he envelops your object. And you get to him by calling the most important API in COM+, CoGetObjectContext. CoGetObjectContext reaches out and touches the walls that surround you and allow you to do things with the walls. Make sense? All right. Your context is a ordered collection of named context properties. And this is really confusing because the word attribute and property are kind of the same in most people's minds. I try to be really precise, though. When I use the term attribute, I'm talking about the things that are stored in the catalog on disk. When I talk about properties, I'm talking about the things that get morphed into the context in memory at runtime. So it's like the distinction between class and object, right? Class is something that's code out on disk, and object is something that's in memory at runtime. So attributes live on disk, and you can think of context properties as being the instantiation of the attribute, although that's a little bit naive, but not by much. Okay? So the idea is your context has a bunch of properties in it which are there, and what goes in your context is influenced by the attributes of your class. That's the way the model works. We can reach out and touch the properties ourselves, and additionally, a variety of pieces of plumbing know about our context. In particular, the data access technologies you use every day know about context and will look in the context to see if you have a transaction and will enlist your database connection if you do. And if you do not, they will not enlist your database connection. Right? That's the canonical example of context. All right. So there's the picture a little bit more accurately. Right? We have your object, which is inside of there, and then we have a bunch of properties which are accessed by name, and you can get to them. By the way, another property you use all the time is request and response, and server and session and application. ASP stores the object model for ASP as context properties, and that's how you get to them since IIS4, which I can't assume anybody would run IIS3. Those people switched to Linux long ago. Okay. Now, remember the console. I did not waste time with the console because I was wasting time. That is the conceptual model from which all this stems. Remember in the console how if I was in a Windows shell, you know, the Windows Explorer shell, and I double-clicked the console app, a new console was created. But if I ran it from the command line, it just reused the same console? Well, there's this notion of propagation of context properties. And when I call co-create_instance, what happens is we try to propagate the context. In fact, we try to propagate the entire context, so you live in my context. So what happens is, at co-create_instance time, we look at the requirements of the target class, and we compare them to the context that we are currently in. And if your requirements are such that you're perfectly willing to live in this context the way it sits now, we actually load you in this context. So the creator and the createe share a context. But if at least one attribute says, oh, I'm not going in there, it smells bad, right? Then we make a new context for the new object. And the new object goes in there. The old object stays up here. But it may have just been one attribute, the smell attribute, that you didn't like, right? Maybe everything else, the taste attribute, was great. We would like to propagate as many of the context properties to the downstream context. The same way we propagate the console handles from the one process to the other. So here's a picture. Object A calls co-create_instance against class B. And let's say that class B is a non-configured component. Non-configured components have no special needs, so they're not talking about how we smell or look or taste. So what's going to happen? The console just grows to envelop him as well. But when B calls co-create_instance on C, and C is a configured component who has at least one attribute who says, I ain't going in there, what happens is a new context is created, and we try to flow as many of the context properties as we possibly can. But of course, there was at least one that couldn't move. That's why we did this. Well, when C creates D, we go for it again. And notice that we hop one hop at a time. So we propagate one hop at a time. But of course, if we propagate it from the first one to the second one, and we go from the second one to the third one, it feels like it flows all the way down. That's what property 4 looks like. But really, all we're doing is propagating from the second context to the third context. Make sense? And so if one of those is the transaction, like if prop 3 was the transaction, then all 4 of those objects will share a DTC transaction, and they can share locks in the database. Right? If that was an apartment, they would all live in the same apartment, and they would all be accessed by the same group of threads. Okay? And so on and so forth. All right. So if 2 objects live in different contexts, how do we cross context boundaries? The way we do it is via proxies. When you call co-create instance and we create a new context for the new object, you do not get back a raw reference. Rather, you get back a proxy. And the primary role of that proxy is to keep this guy working, to keep the pointer in TLS in sync with the context of the object that is currently executing. Okay? So that's what we get. The proxy, conceptually and in many cases physically, keeps 2 pointers or 2 references, a reference to the target context of the object and a reference to the object itself. So it knows which object in that context we're going to invoke on. And when you invoke a method on the proxy calls a well-known method on the context that says, please go call this method on this object on this interface and return to me the 8th result. And that method on the context then does the TLS flip, does the work, may run some other services as well, as we'll talk about later. Right? But that's how we actually do the transition, through proxies. All righty? Hold on. I have not drawn for you yet, have I? Watch this. See this? I am going to draw a diagram for you dynamically. That's a thread. That's the international symbol for thread. I know many of you guys don't get overseas, but in Europe, you go down the roadside on the Autobahn and stuff, that's what a thread looks like. Well, you guys are tired. Okay, I got 3 threads here. I'd like to see you draw with 1 finger. Don't laugh. I'm doing my best. I am deliberately trying to draw this as cleanly as possible, which is sad. So let's say we have 3 threads here, A, B. Often when COM is really sinking in, you hear a slight ringing in the back of your ear. Okay, so thread B. By the way, those lines around them, those are process boundaries, okay? So thread B calls create file. What does create file do? It opens an I/O device handle to the file system so you can do I/O against a file. Agreed? Thread B passes the file handle to thread A. And thread A performs an I/O request. What happens? The I/O is performed. Why? Why is that okay? Why was it okay to pass from thread B to thread A? Because it worked. That's why. Now, thread B calls create file a second time, gets back another file handle, and somehow magically passes the 4-byte handle value that he got back to thread C. And thread C does the I/O operation. What happens? Results are undefined. So why is it that thread B cannot pass the handle to thread C? Because it doesn't work. Right? It's very simple. B to A, it works. B to C, it doesn't work. Handles only work in the process in which they are initialized. Would you buy that? Okay. Now, let me change the diagram ever so slightly. Let me say that these are COM objects and not threads. So ignore the fact there's an arrow. And let's say that these are contexts, not process walls. Okay? Thread B calls co-create instance and acquires an object reference. Puts it in a global variable and says, okay, A, go make a method call. What happens when A makes the method call? It works. When thread B takes that same object reference, just puts it in a global variable, and tells thread C to go make a call, object C to go make a method call on it, what happens? It doesn't work. Because object references are context relative. And they only work in the context in which you initialize them. And the results are completely and utterly undefined what happens when you violate that law. Now, it would be legal if I was holding a proxy. Here's a proxy. If I was holding a proxy to C, it would be legal to pass the object reference as a parameter to a method, because the proxy's job, one of the proxy's job, is to fix up the object reference so it works for C. But if I just store it in a global variable and don't let the system get involved, I'm screwed. It's going to fail miserably. Okay. So object references are only valid in the context in which they are initialized. You can't store them in global variables, which is cross-context state. We use proxies, and proxies will do the right thing when we pass things as method parameters. And if you want to put things in global variables, you need to use a system-managed facility like co-marshal interface or the global interface table. Okay? Now, oh, I love this one. I'm going to, in case, the Justice Department is here, and I'm called to testify in a court of law, I have to watch my speech here. Configured classes typically require a new context. So when I call co-create instance on a configured class, virtually all the time, a new context will be created for that configured object. Non-configured classes typically wind up in the context of their creator. Okay, those are generalisms which are 98% of the time true. In either case, you are bound to the context in which you are initialized. So when an object is born, it's born in some context, and all subsequent method calls will happen in that context. So if you have a transaction on method 1, you're going to have one on method 100. If you don't have one on method 1, you're not going to have one on method 100. You're going to have a consistent, predictable runtime environment across method invocations. However, you have some flexibility. If you are a non-configured code, you have if you're a non-configured object, you have the ability to implement this magic interface called iMarshal. And iMarshal allows you to do one of two things. One of them is marshal by value. That's a very common application of iMarshal that says, instead of passing proxies to me, just duplicate, clone the object, and make a clone when this thing gets passed across the context wall. Very common technique, especially when using DCOM. The ADO record set marshals by value. That's like the most common, popular thing that does it. The other thing you can do is to become context agile, which says, I do not want to be bound to a particular context. Rather, I want to always execute in the context of my caller. And I want everyone to always have direct references to my object. And when you are context agile, we use this mythical, mystical phrase that, just has all this mystique in the industry called aggregating the free-threaded marshaller. And when you go home tomorrow and your spouse, talks to you about your experiences here, I think you should say to your spouse, honey, tonight we're going to aggregate the free-threaded marshaller. And your spouse will respond in ecstasy. Do you know why? Because components that do not aggregate the free-threaded marshaller, that are context-bound, are always touched in the same place every time. Components that aggregate the free-threaded marshaller are touched all over. Here's a context-bound object. Notice that the object lives in the context in which it's created, and everyone winds up with proxies to it. And those proxies always come home to context A before calling your method. Boring. That's what it means to be context agile. You can be accessed from any context, and each method will have unpredictable characteristics. Some methods you'll have a lock, some methods you won't. Some methods you'll have a transaction, some you won't. Sometimes you'll be checked against one DACL, sometimes you'll be checked against a different DACL. The idea is you have no control, but you don't want control. You want to just lose control and let it go. All right. Non-configured objects and context agile objects are similar but different. And this slide really draws the picture really well. If you're a non-configured class, that is, you write a piece of code in VB or ATL and you just reg server 30 to it, what do we know about it? It's going to be accessed directly unless the caller is outside of the context of the creator. So your creator will have direct access to you, but if he passes references to you around, they're going to get a proxy and it's going to be a switch. Whereas with context agility, there's never a proxy. You're always being accessed directly within the process of the creator. With non-configured code, the methods execute in the creator's context, With context agile objects, the methods execute in the caller's context. And then finally, non-configured objects can hold object references because they always live in the same context. So if I acquire an object reference in method A, I know that method B will execute in the same place, so I can use the object reference again. If I'm context agile, if I acquire an object reference in method A, method B is going to come in on a different context. I can't use that object reference as if I store it as a data member. So I have to use the global interface table or something of that nature to be able to make sure that the object references that I hold are also context agile, which means I use the global interface table. And for that reason, objects that aggregate the free-threaded marshaller and use the global interface table are often slower than context-bound, non-configured objects. Because if you have to make 3 method calls using the global interface table, it's slower than just taking one context switch. Configured classes have 2 ways of influencing their relationship with context. There's this notion of object pooling, which allows your object to be created prior to the context being created. And then we associate you over time with different contexts. There's also this thing called just-in-time activation, which allows you to detach from your context while the proxy is still in place. And the caller is unaware that this is happening. And at the next method call, we will make another instance of your class or get another instance from the pool. So here's an example. We have a client context. That's the one you see on the left. And you see a pool of instances in inventory that is ready to go but not in use. Caller calls co-create instance. We create a context, and we bind an object to it. We then dispatch the method call. And assuming I support just-in-time activation, I can set the done bit, which is that bottom context property, which will cause the object to go back into inventory. At the next method call, we'll actually wind up with a different instance of that same class. Statistically, it would be an accident if we had the same one twice. And the call gets dispatched there. The client is completely ignorant. All right? And then finally, we go away, we release that, and when we release the context goes away. So this drives home a really important point. The client is holding a reference to your context, not your object. Your object is just another context property. And if you think of it that way, your life is so much better. You realize you're just the user extensibility point in the context infrastructure and a place to put the attributes. Okay? All right. Here's some example attributes in context. There's a threading model attribute. It influences apartments. And apartments are used to regulate which threads talk to which contexts. There's a synchronization attribute which controls this thing called an activity, which is used for allocating threads as well as for managing concurrent access to contexts. There's a transaction attribute and a transaction stream context property, which is used to manage DTC transactions with components. And finally, IIS, the WAM, and ASP put context properties for the object model for ASP. So ASP components can do request.write and response.read, or no, it's the other way around. Response.write and form variable, this, that, the other thing. So to wrap up, COM components are typed and self-describing via type libraries. COM object references are typed via abstract interfaces. COM objects are typed via concrete classes. And COM classes get annotated via these declarative attributes. And these attributes are then use context to augment instances of the classes. When in doubt, think about the linker switch. Think about the console app. And everything that the console app does has an analog over here. And a lot of you understand the console paradigm, and that's a great way to just bring that knowledge over. Okay? So I'd like to thank you. It's been a fun TechEd. I'm going home. See you later. Bye.